So we are out here on July 19th, just taking some measurements on our sequoias. We've been measuring the change in height of the entire tree over the last month, a little over the last month. We have 3 trees in this pot here, and we have 3 trees in this pot down here. We started measuring on the exact same date. We use the same soil, they get the same amount of water, the same fertilizer. The only difference, well, they get the same amount of sunlight as well. The only difference, the one thing we are changing in the experiment is one pot has a Neo 52 high-powered magnet on the top of the soil with the northern field facing up, and our other pot does not have a magnet. So we've been tracking our height in all 3 trees of each pot. We've been mapping out what that looks like, and I wanted to just show you what our results look like thus far. So the top chart are our numbers up until July 19th without magnets. As you can see, our initial average height was 8.5 inches. And then that average height has slowly increased to 10.58 inches up until July 19th. That signifies a 25% change in height, amounting in 2.08 inches. Our bottom chart reflects our measurements and calculations from our 3 trees that are in the pot with the magnet. We had an initial higher height of 9.08 inches, and those trees continued to grow over the last month. You can see in week 2 that actually, and I mean, there's probably a small percent error with the actual height, but doing the averages and having 3 trees does help minimize the percent error. But in week 2 on June 24, you can see there's an 8% rate of growth change with the no magnet trees and only a 7% change with the magnet trees. And then July 1, the percent change in growth compared to the first week was at 19% with no magnets and 16% with magnets. So after the first 2 measurements, the trees with no magnets, we're growing at a slightly faster rate. But then if we go now to a little over 30 days out, when we look at July 19th, we can see that the no magnet trees increased their average height from 1.58 inches taller to only 2.08, which means a ½ inch taller. But if you look down here, our magnet trees increased a full inch from the last measurement date, from 1.42 to 2.42. And then what that did is it boosted the percent change of growth from 16% to 27% versus 19% to 25% with our non-magnetic trees. So then what we do with that data is we throw it into a chart here. So this is just the overall height of the trees averaged together. You can see that the 2 lines that represent the 2 pots are pretty parallel throughout the graph. But then right up here, you'll notice that the orange line, which represents the magnetic trees, definitely increases its distance from the blue line with a sharper, steeper slope from the last data point. If we go down to our second graph, this graph's the percent change. You can see they were pretty even, like we said, on the first measured date, 7% versus 8%. The non-magnetic trees grew between the second and the third data point, 19 to 16. But then on the last one, the magnetic trees had quite a spike and now have overtaken the non-magnetic trees with the percent growth. So pretty cool stuff. We'll see if the magnetic trees maintain that growth percentage into the next measurement date or if they don't.